0 vector, right? So there are two ways I can write it. One way I can write it as 0, 0, right? Or I can write it as that bold-faced 0, right? 0 vector. What is the magnitude of the 0 vector? 0. What's the direction of the 0 vector? Doesn't really have one, right? So where's this thing going to go? It would just kind of sit at the origin, right? Well, that's not very interesting. We need a different one. So let's go ahead and swap out. Let's do 1, 0. When I plug in 1, 0 there, what is my x component going to be? What is my first component going to be? It's going to be 0, right? Y is 0, right? I plug in here. I'll have 0i plus 1j, right? Which just gives me j. What component is j? X or y? Y. Okay, ask some questions. I can tell several of you are confused. I'm taking these points and I'm plugging them into the given equation. I know I screwed with all of you by swapping this. If the x had done with the I, it would have made more sense, right? But the important thing here is those are just functions. This is my p, that's my q, right? I mean, they can be anything I want. I mean, it could be something like e to the y minus sine y if I really want to make life difficult. Okay. What does this tell me? Where's my vector headed? Straight up, right? How long is the vector going to be? 1. How can I calculate how long the vector was? I can look at the magnitude, right? So really quickly, I'm going to add in one more column here. I guess we drop the second one. To find the magnitude, I take the square root, right? And what do I do with each of the components? Where I'm an atom, right? Sweet. Length 1. Well, I could have seen that for that example, right? Okay, we need some more points to plug in here. Let's go ahead and go with 0, 1. I'm choosing nice points, points that work really well for them. Okay, if I plug in 0, 1 here, I'm going to come up here, right? And actually write it over here. I'll have f of 0, 1, which will give me negative I, right, plus 0j. Is everyone okay with that? Good? So this vector is going to be negative 1, 0. What's the magnitude of that vector? 1. Okay? So I'm getting kind of an idea here. Really, I have no idea what it looks like yet. I'm just getting some information. Plug in a couple more points. Let's plug in negative 1, 0. 0, negative 1. Notice I'm choosing points pretty close to the origin, smaller numbers just to get an idea right now. And then we'll move out. Give me a second, let me find those ones. When you plugged in negative 1, 0, what did you get for your vector? 10, 0. Negative 1 look good? And how about for the last one? What did we get for the last one? 1, 0. Is everyone okay with where we're getting these numbers? Yeah. Okay, so what we want to do is we want to take the points we already have and use them to sketch the vector field. To do this, I'm going to come over and start with my x and y axes. And I'm going to use all the information I have right here. I'll go ahead and fill these things, or I'll make it too long. So I'll start with this one, because the 0, 0 isn't especially useful. So, starting right here, I need to go out to the point 1, 0. So I'm going to go out to the point 1, 0. That's right there, right? And I'm going to draw a vector that is 0, 1. Now, I came out to the point 1, 0. My vector 0, 1, where is it going to be headed? Straight up, and what's the length of it going to be? 1. So I'm going to come over here, I'm going to draw a vector that heads straight up, that length 1. draw the vector. Now, a vector that's negative 1, 0, where is that vector pointing? Left, right? Because this is the x direction negative, and it's going to be going that direction 1 unit, right? So let's take this and we're going to go 1 unit forward that way. Good? Okay, I'll go to the next one. I go to the point negative 1, 0. And where is the vector for that one going to be heading? Down, right? Because it's 0, negative 1, and how long is it going to be? Unit. Okay. Final one here. I go to the point 0, negative 1. And where is that vector going to be headed? What? 1 unit, right? Now, one of the cool things about vector fields is it can show us motion. One of the reasons vector fields are used, or one of the places they're used, are to map currents in the ocean or wind flow. So, for instance, if you had an ocean current here, this wouldn't make much sense, but what this would mean is that at this point your water is headed this way, at this point it's headed this way, at that point it's headed that way, at this point it's headed that direction. What kind of shape does this look like it's making? Don't overthink it. Looks like it's kind of like a squarish shape, right? So the question is it actually a square? Okay, sorry. I was going crazy. I was thinking that's not my phone. I know that's not my phone. Okay. Better you than me. It's okay. So what we want to do is we want to figure out what exactly this looks like, and to do that we need more points, right? So we've only got 4 points up here. Some of you are shaking your head, no, I know what it looks like. Well, you're going to humor me and we're going to find some more points anyway. So, let's go ahead. X, Y, and let's try and find some points on here. Now, I have a theory about what it could look like. So what I'm going to do is I'm going to go ahead and I'm going to choose why would I do this? Okay, well, let's think about it here. Plug it in. Okay, what is my x component going to be? Well, in my vector, my first component, yeah, you can say I. What's it going to be? It's going to be negative root 2 over 2, right? Okay, and my y component? Root 2 over 3, right? Okay, this is interesting. Is my vector headed left or right? Left. And is it headed up or down? Up. So it's headed this direction, and what I really need to know is what is the magnitude of this jump. Well, to find the magnitude, I take the square root, right? I square the first one, which will give me 2 over 4. Square the second one, which will give me 2 over 4. What is the magnitude of the shenanigans? 1. This is interesting. Take it over here. Okay, I'm going to go to the point root 2 over 2, root 2 over 2. Root 2 over 2. I want to go to the point over here. What is root 2 over 2 approximately equal to? Well, you guys have phones, you have calculators. Come on, someone tell me what root 2 over 2 is the same as. I need a decimal for it. I can't visualize that on my graph, right? So I need an actual point. Come on. Oh, wait. I'm patient. 0.7? So is everyone okay with if we use 0.7? I think it's like 0.707 something. So I'm going to come over here to about 0.7, and then about 0.7 up, right? So I'm mapping the point root 2 over 2, root 2 over 2. I'm going to come right here. Right around there, right? And this is headed left and up. And the big question is, what angle is this headed left and up at?
45.
How do you know it's 45? I don't want you to tell me anything about the unit circle.
Yeah, the even, remember?
These are the same, right? It's got the same x and y component, which means I've got to be headed up at a 45-degree angle, and it's magnitude 1, right? What's that? A little bit more right? I'm correcting my drawing. Did I leave it?
No, I mean, it goes with one light, magnitude one.
Yeah, so it'd go a little bit further over, yeah.
So it goes y axis, right?
Oh, yeah. Well, yes.
I'm not trying to correct you, I'm just
No, yeah.
Okay.
This is the component, yeah. Yeah. Let me think about it just a second. First. Okay. Question, guys, are we forming a square here? What are we going to be forming? A whirlpool, right? A little circle thing. Important to note, it's not actually a whirlpool, because if I followed this around here, I just keep going, right? It's almost like a cycle going around. In fact, if I drew a sketch around those or on the inside of those, what do you think it would form? A circle, but specifically what circle? Unit circle, right? And that's because each of these points I'm pulling here are a radius 1 away, right? And so if I can fill it in here, if I can kind of guess at what this is going to look like that, right? And around all the way. Now here's the important thing. That's just one part of my vector field, right? There are infinitely many other vectors in it. And so what we can do is we can take these points we've had and we can actually move them out to look at the behavior further on. So what we're going to do is we're going to look at one more, probably 2 more points. Let me go ahead and I'm going to make it 3, 0. Now what we're doing here is kind of exploring what the vector field looks like beyond that one little circle I've got in the center there. I want you guys to think, I want you to be kind of impressed with yourselves that you were able to get that off of those too. Most of you had seen it, I think, and as soon as we graphed that, like, it's not going to be a square, it's totally going to be a circle. That's really awesome to have that intuition. That's really cool. Okay, 3, 0. What are my coordinates going to be? 0, here and 0, 3. What do you think, guys? That's good? Yes. Okay, so if I come up here and graph that, I'm going to go out to 3, 0. 1, 2, 3. And what's going to happen with that vector? It heads straight up and longer, right? Okay. Let's do one more. Someone choose a strategic point for me here. How's it here? You think we can see it like that. If I chose 0, 3, what would my vector be? 0, 3, 0. Which means if I go up to 3, 0, 1, 2, 3, where's my vector pointed? Left. What do you think is happening here? If you had to visualize what this is going to look like. I have the inside one. It'd be the same kind of thing, right? And the same kind of thing, and the same kind of thing. What's really cool about this is normally with vector fields, if we have patterns like this behavior, we can see it after only graphing a couple vectors. Not all of them are going to be this symmetric novel. All of them are going to be this nice. But just really quickly, to kind of visualize what we have going on here. I have the same kind of behavior all the way out, right? And it'll be out again, and out again, and out again, and each time we're tapping into those vectors. They're getting longer and longer and longer. And this is one of the reasons why if we have really, really long vectors and the pattern is really repetitive like this, it's also easy to graph them based on the size instead of the length. That is, I can graph the inside one as smaller, the next one as a little thicker, the next one is even thicker, and so on. What that allows me to do is put more vectors in there without it looking really, really crowded. And so the thickness corresponding to the magnitude also.